All right, this is AP, AB, and BC Calculus, and we are doing Unit 6, Section 5, which is interpreting the behavior of accumulation functions involving area. All right, so let g of x be defined as the integral from -2 to x of f of t dt for x values between -2 and 6. So the graph of f of x consisting of a semicircle and two line segments is provided. What is the value of g of 6? Okay, so let's start with A. What is the value of g of 6? And this is a pretty typical way that you might see a free response on an AP. This entire section will be a lot of prompts that could be free response in an AP. So let's look at A. So for A, and we might end up having to scroll down a bunch of times when we run out of room, but that's fine. So g of 6 should be the integral from -2 to 6, right? I'm copying this formula right here, of f of t dt, which means the area from here to here of this graph. So essentially what I'm looking at here is I'm looking at semicircle plus this triangle plus this other triangle, right? Where this is above the axis, so it'll be positive, this is below the axis, so it'll be negative, and this is above the axis, so it'll be positive. So let's just go ahead and find those areas, right? So this is semicircle, 1/2 pi, the radius is 2, so 2 squared, which will be 4, plus the easiest way to notice that this comes out negative is to make the height a -2, and the base is a 3. So this is 1/2 the height times the base. And again, what's important here is that that net's negative. You just need to be aware, because sometimes you can't naturally make the negative happen. You have to understand that it's negative, and this is a base of 1 and a height of 2, so that'll be a plus 1/2 base times height. So I get that this is a 2 pi minus 3 plus 1. So I get 2 pi minus 2. So that's my answer to A, right? So g of 6 is a 2 pi minus 2. And you shouldn't change a number in for pi. You should leave it as is. All right, part B. On what intervals is g of x decreasing? Justify your answer. So in order to do these prompts, you have to say, wait a second, what would it mean for g to be decreasing? So g of x is decreasing. What that means for us is that g prime of x is less than 0, right? That's what we're looking at. So what that tells me is, oh, I need g prime. All right, so let's go ahead and look at what g of x is. G of x is the integral from -2 to x of f of t dt. So g prime of x is going to be the derivative with respect to x of this thing. Well, we've seen from the second fundamental theorem of calculus that those cancel, and my g prime of x is going to be f of x times the derivative of x, which is just a 1, minus a bunch of 0 because of this whole derivative of -2. So it turns out that g prime is just f of x. Well, now let's go back to this flowchart. So I'm looking for when f of x is less than 0. Well, that means that I'm looking with my eyeballs for when the given graph is below the x-axis, because that's what it would mean to be negative. So that's what I need to find with my eyes, and that's how I'm going to find my answer. So I go back up. I want when the given graph is below the axis, and the answer is from 2 to 5. So my answer is 2 to 5, right? Or the other way to answer that would be to say 2 is less than x is less than 5, but I always prefer this. And this is my justification, right? I walked through and said, this is what you asked me. This is what it means mathematically. This is how it translates to the function I can see with my eyeballs. This is what my eyeballs are looking for. Boom, there's an answer, right? That's my justification. All right. C, on what interval in the open interval from -2 to 6, in the open interval from -2 to 6, my bad, at what x-coordinate does g of x have a relative maximum? Justify your answer. So now we want g to have a max, okay? So, oh, and notice they said open interval. That means endpoints are off the table, right? So let's look at C, right? If g of x has a max, right, that means that g goes from increasing to decreasing, right? Well, that means that g prime goes from positive to negative, but we've seen that g prime is the same as f, so we want f to go from positive to negative. So that's what I'm looking for with my eyeballs. What I want to see with my eyes is when does the given graph cross from above the x-axis to below the x-axis. That's what I need, right? That's what's going to make a relative maximum. That's what I'm looking for. And so then I can look when I scroll back up to my graph and I can get my answer. So when does the given graph cross from above the x-axis to below? Oh, hey, it's at x equals 2. So my answer is when x is 2. And when I'm asked to justify, I just did, right? My justification was that the graph switches from above the x-axis to below the x-axis. I clearly explained why it was f that I cared about, not g. All right, last one. On what interval is g of x concave up? So when you read C, your brain needs to, or sorry, when you read D rather, right? If you want g to be concave up, g is concave up if g double prime is greater than 0, right? But I don't know g double prime. So my brain says, ooh, I need g double prime, right? Well, I know that g prime of x is the same as f of x, so g double prime of x must be f prime of x, meaning I'm looking for where f prime is greater than 0. What that means with my eyeballs is that I'm looking for the given graph has a positive slope, meaning the given graph is increasing, right? I want when the given graph has a positive slope or is increasing. So I go up here and I look and I say, okay, cool. Well, the given graph has a positive slope here and here. That's it. So I say from -2 to 0, right? Because I want the x coordinates, so -2 to 0, and from 4 to 6. Those are the windows I want. So my answer, -2 to 0 and 4 to 6. And again, my justification came from all of the steps along the way when I'm able to logic through what I need based on the given graph. This is a really common AP free response. This one personally is not an AP free response. This is one that I made as a graph on Desmos and then made as a problem, but this exact kind of problem is really common on the AP. So this is going to be a longer video just because, as you can see, each one of these prompts takes a decent amount of time. All right, go ahead and try this without me. So g of x is the integral from 0 to x of f of t dt from 0 to 5. You can see the graph from 0 to 5 consists of a semicircle and 2 line segments. All right, so go ahead and pause me if you want. I'm going to walk through it. So for A, right, g of 5 should be the integral from 0 to 5 of f of t dt, right? So keep in mind that this area down here has to be negative, right? But this is going to be this negative semicircle, right? Plus, I'm probably going to break this into a triangle and a trapezoid. I think that's probably the easiest option. So plus triangle plus the trapezoid, right? And again, they're both positive because they're both above the x-axis. So the trick here is you can't make this negative by just calling the r a -1 because you're going to square it. So you have to recognize that this is a negative. So because it's 1 squared and then pi, right? So you're going to get a negative pi over 2 for the circle. Plus, you've got a base of 2 and a height of 4, right? So 1/2 base times height is going to give you a 4, right? And then this trapezoid has bases of 4 and 3 and a height of 1. So plus, this is a 1/2, 1, and then 4 plus 3. So you're going to get a 7/2. So it's not pretty. You're going to end up getting that g of 5 is a negative pi over 2. And you're probably going to make this a 15/2, right? Because that's 8/2. So probably this or something equivalent. You could do a 7.5. It doesn't matter. Okay. So B, C, and D are all going to rely on that second fundamental theorem of calculus for us to differentiate. So notice that B is asking when G is increasing. So your first and foremost job is to recognize what this is requiring you to answer with, right? So if you want to know when G is increasing, right, the first thing your brain should say is, oh, that means G prime is positive, right? And then your brain should hopefully make the leap that I need, so we need G prime, right? Like we have to find G prime. So since G of x is the integral from 0 to x of f of t dt, G prime of x is just going to be what happens when you knock the integral out and you get f of x. And if you need that extra step where you write the d dx, that's fine. So what this is saying is we want f to be greater than 0, meaning we want the given graph above the x-axis. So then I go up and I say, okay, cool, I can see with my eyeballs where that's going to happen. If I go up, I see that that happens from 2 till 5. So my answer is 2 to 5. And at 5, it is actually positive, so I'm going to put a bracket there. At 2, it's not actually positive. At 2, it's actually 0, right? But at 5, it is physically above the axis. For C, so in C, I'm asked, when does G have a relative minimum, right? So, and notice it's an open interval, so I don't have to worry about the endpoints, right? Ignore that weird minus. It's not supposed to be there. So the window from 0 to 5, right? When do we have a relative minimum? So G has a relative minimum, right? Means G is going from decreasing to increasing, right? So decreasing to increasing. That's what G is doing if it has a minimum, right? Which means that G prime is going from negative to positive, right? But we have established that G prime is the same as F, so we're looking for where F goes from negative to positive. And what that's going to mean we're looking for with our eyeballs is where the given graph crosses from below the x-axis to above the x-axis. That's what we're looking for with our eyeballs, is where the given graph crosses from below the x-axis to above the x-axis. And then sure enough, if we look up here, we're going to find our answer, right? Given graph crosses from below the x-axis to above the x-axis right here, right at 2. So x equals 2, okay? And then for D, we want what interval is G of x concave down? Well, remember, it's easiest to say, okay, cool, I know G is concave down is the question I'm being asked. What does that normally mean? Well, that means that G double prime is less than 0, right? But I need a relationship between F and G. So this tells me, ooh, I need G double prime, right? So I know that G prime of x is F of x, which means G double prime of x has to be F prime. Okay, well, that was the mystery information I needed. So that means that we're looking for where F prime of x is less than 0, right? Which means we're looking where is the given graph. You can either say decreasing or has negative slope, right? So that's the same as saying has negative slope or where is the given graph decreasing. So I'm going to go look at the graph, right? It's hard to see because I scrolled all the way down, but I'm going to scroll up in a second. I'll get my answer, right? So my answer, if I look where the given graph is going downhill, it's here and here. So that's from 0 to 1 and from 4 to 5. So 0 to 1 and 4 to 5. And they, yeah, so 0 to 1 and 4 to 5. All right. And I'm going to argue that, notice that it is actually negative at both of these endpoints. That's a negative slope. Well, that slope is undefined. So we're going to go ahead and leave that one as a parenthesis, but this one's definitely a negative slope. The slope is definitely negative at 5. All right, cool. So there's my answer, right? And again, my justification was all the logical steps I took along the way from what was the question asked, what does that mean mathematically, how can I relate that to what I'm given, what can I see with my eyeballs, boom, there's an answer. All right. Example 2, let g of x be the function defined as g of x equals the integral from 0 to x cubed of f of t dt. So we're given f of x, and we're asked to write the equation for the tangent line of g of x at x equals 2. So before you panic about everything else, because this keeps happening on free responses, I want you to read the prompt, and I want you to see what you need, right? And if you notice, go back to the other 2 examples I just did. That's exactly what I did, right? I read the prompt and said, what does that mean I need, right? And then I thought, okay, how do I find that information? Read the prompt, think what you need. So I read this prompt and I say to myself, oh, I need 2 things. I need a point, right, which is going to be 2 comma whatever g of 2 is. So I'm going to need to find g of 2, right? And I need a slope, which I know is going to be, since it's the tangent line, g prime of 2. Once I know that, my brain says, oh, I need g of 2, and here I need g prime of x, then I need to plug in 2. Right? Those are the 2 things I need to do. So let's start with the easier of the two, right? So let's start with the first thing I need. I need g of 2. So g of 2 is going to be the integral from 0 to, now this isn't an x, right? That's an x cubed, so 0 to 8 of f of t dt. So I'm going to go ahead and find that area. Well, the integral from 0 to 8 is going to be this trapezoid plus this triangle minus this triangle. And I would like to point out that these two are the same shape, exactly the same above and below the axis, so they're actually going to cancel. Plus, oh, and actually, so it's up to you. You could do the bottom one as one giant triangle if you want. It's up to you. So the bottom one is a big triangle. That didn't work for the first one, right? This piece and then plus this piece. So g of 2 is going to be, my base is a 1 and a 3, my height is a 2. So I'm going to get that it's 1/2 the height times the sum of the bases, right? That's the trapezoid, so we'll call that A. And then I have a triangle, we'll call this B, so this was A, right? B was 1/2 the base of 1 and the height of 3, so 1 times 3, right? That's B. This thing's going to net negative because it has a height that's negative, or just because it's below the axis, right? So the base of this is 1, 2, 3, 4 units. The height is -3. So I'm going to get 1/2 -3 times the 4, right? And then this seems to have a height of 1 and a base of 1. So this is that was what I called C, and then this one's what I would call D, right? So plus 1/2 base times height. So it's ugly, but that's how I'm going to find it, right? So when I clean this up, the 1/2 and the 2 cancel, so that's nice. So I get a 4 plus 3/2. And then I'm going to get a -6, right, plus a 1/2. So I seem to get that this is 4 plus 2 minus 6. Oh, look, after all that, I get a 0. So that was a lot of work to get that g of 2 was a 0. Okay, so now I have my point. I know that it's, so first part of my work is done, right? My point, after all that work, was 2, 0, which seems kind of crazy, but it is what it is, right? Now I need my slope. So in order to find my slope, I know that g of x was the integral from 0 to x cubed of f of t dt, right? Which means that g prime of x is the derivative with respect to x of that integral, right? Which is going to knock out the integral and just give me that I get f of x cubed times the derivative of x cubed minus a bunch of 0 because it'd be f of 0 times the derivative of 0. So after all that, I get that g prime of x is just a 3x squared times f of x cubed. Great. So that's what I need to find. Now I need my slope to be g prime of g prime of 2 rather. So my slope, g prime of 2, should be a 3 times 4 times an f of 8. Well, we can see up here that f of 8 is a 1, right? F of 8 is a 1 on the graph, right? There's f of 8. So I get that this is a 12 times 1, or just a 12. So now I have a slope, right? So I now know my slope is 12. I know my point is 2, 0. So after all that, I can get my answer to be y minus the y value equals mx minus the x value. And that's the best version of the answer. You could ignore the y equals 0 if you want, or the 0 if you want. You could also write this. You could also write this, but again, I wouldn't recommend it. I would recommend you do the laziest version. So that's not a short problem, but it's not a difficult ask. If you think about, so the first thing I need you to do is, before you panic or clam up, I need you to stop and think, okay, what was the prompt? What would I need to accomplish that goal? And maybe you stall somewhere in the middle, or maybe you add wrong, or you find the area wrong, and we've all done that. But don't panic when you see it. Read the prompt first, and then reverse engineer what you need from there, okay? That's the important thing. All right, so moving on. You're going to try the same basic thing. So g of x is the integral from x squared to 6 of f of t dt, right? The graph of f of x is here, and you're going to write the equation of the tangent line to g at x equals 1. So go ahead and try it without me if you want. So just pause me. I'm going to walk through it. So I see this, and I say, okay, I definitely need two things, right? I see this and think, okay, I need a point, which is definitely 1, blank, and that blank is going to be g of 1, right? And I need a slope, which is definitely going to be g prime evaluated at 1. So first thing I'm going to do is find g of 1. So g of 1 is the integral from 1 to 6 of f of t dt. Well, here's 1, here's 6. So it seems to me that the easiest option is to do a trapezoid, a rectangle, and then 2 triangles, right? So, and honestly, you could also physically count boxes almost, like not entirely, but almost. So so when I find this area, right, this is a base of 1 and a height of 2, sorry, two bases, base of 1 and 2 and a height of 1. So I'm going to get 1/2 the height times the sum of the bases, right? Plus, this is just a square, right? It's 2 by 2. Plus, this is a height of 2 and a base of 1, right? So 1/2 1 times 2, right? And then this is exactly the same. So these two triangles are exactly the same, but above and below the axis. So basically what's going to happen is they're going to just cancel each other out. So it's a positive 1 and a negative 2. But either way, these guys sum to 0, right? And what ends up happening is I get that this is 3/2 plus a 4, right? So that should be 11/2. Which checks out, right? Because it's 5.5. So I get that my point, and you could use 5.5 or 11/2, I don't care. So I get my point. Great. First half of the work is done. The next thing I need is I need to take this and I need to find my g prime, right? So if I come down here, we know that g of x is the integral, sorry, I just have to double check. It was an x squared. From x squared to 6 of f of t dt. So g prime of x is going to be what happens if I differentiate this. So when I do that, these cancel, and I'm going to get 0, because remember, when I plug in f of 6 times d6, the d6 is just going to go away, minus f of x squared times the derivative of x squared. So it seems that my g prime of x is a negative 2x times f of x squared, which means g prime of 1, I think we wanted 1, yep, is negative 2 times 1 times whatever f of 1 is. Well, let's go up to f of 1. F of 1 is a 1. So I get negative 2 times 1, which is just negative 2. So there's my tangent slope, right? So once I know my tangent slope, I can come up here and write my answer. My final answer is going to be y minus the y value equals my m, which I think we just said was a negative 2, m x minus the x value. And there's no incentive to clean that up. Like, please don't. If you want the 11/2 to be a 5.5, that's fine, but don't clean it up. It doesn't help. All right, moving on. All right, let g of x be defined as the integral from x to 5 of f of t dt, and here's our graph of f of x. Sorry, ignore my random stray mark. Identify the x coordinates of all relative extrema of g of x, label each as a relative max or min, and justify your answer. Okay, so we don't know anything about the g of x graph except that g of x is the integral from x to 5 of f of t dt. If we're asked about extrema, when you hear extrema of g of x, your brain should hopefully say you need to know g prime of x. That's how we find extrema. We find g prime. So g prime of x is going to be what happens when I differentiate this integral, right? Well, when I differentiate an integral, they cancel and just leave me with the integrand on the inside when I plug in the bounds and get f of t times dt. So this is going to be a 0 because when I plug in the 5, f of 5 is not a big deal, it doesn't matter to me, but d5 is definitely a 0, minus f of x and then the derivative of x. So I end up getting that g prime of x is negative f of x. Cool, that's relevant. Okay, so essentially what that means, right, is that the g of x critical points are going to happen when g prime of x, which is the same as negative f of x, equals 0. I'm going to write or do not exist, but this is clearly a polynomial. Like, this is a nice, happy function, so that's not going to be an issue here, right? Like, look at this. It's nice and curvy. There's no points. There's no cusps. There's no weirdness. So we want when negative f of x equals 0, right? So negative f of x equals 0 when f of x equals 0, which we can see visually happens here, here, and here. So at negative 1, 0, and 3. So negative 1, 0, and 3. So if we want to make a g prime sign chart, right, so we know g prime is 0 here, here, and here, right? So g prime of x is the opposite of f of x, right? So this is my g prime sign chart. Here's what I know. I know g prime is 0 here, here, and here, right? But see how g prime is the opposite of the given graph? Opposite of the given graph. So anywhere that the given graph, right, anywhere that the given graph is positive, right, so like right here where f is positive, that means that g prime is negative. So see how f was negative first, well, negative times a negative would be a g prime that's positive, right? So g prime is positive, right? Then when f is positive, right, g prime is negative. And then from 0 to 3, you can see that f is negative. Well, that means that g prime is positive, right? And then from 3 onward, we can see that f is positive, which means g prime is negative. That means that g is increasing, decreasing, increasing, decreasing. So we have a max at -1, we have a min at 0, and we have a max at 3, right? So, so at x equals -1 and 3, we have so g has a relative max because g prime, which is negative f, switches from positive to negative, right? And at x equals 0, g has a relative minimum because g prime, which is the same as negative f, switches from negative to positive, okay? So again, I don't know anything else about the graph. I just know the relationship between f and g, and I'm looking for sign changes, right? Because that's what we need to know for relative maxima and minima values. All right, go ahead and try a P3. It's the same idea. Again, you're looking for extrema of g of x, which means you need g prime. So here, g prime of x is just going to be f of x, right? Because when I differentiate, essentially if you put a prime here, dx, these cancel. I get this times dx and then minus a bunch of zeros. So I just get g prime of x equals f of x. Meaning that I have critical points, right? So g has critical points when f of x is 0, which is at x equals 0, 1, and 3, right? G prime is the same as f. So we have 0, 1, and 3, right? So g prime is negative before 0, stays negative from 0 to 1, crosses to positive, and then switches to negative, which means that what g is doing is going down, leveling off, and down again. So that's a saddle, right? Up and then down, right? So I should have actually clarified. I should have written or neither because one of these is not a max or a min. My bad. So x equals 0 is neither because g prime equals f does not change sign. So it's not, so actually, I shouldn't say that. You didn't have to say max, min, or neither. So x is 0 is neither. It means I don't actually have to clarify what it is because it's not an extrema, but you get the idea. We have a min at 1, right? So x equals 1 is a relative min for g because g prime equals f switches from negative to positive. And x equals, I think the last one was 3, is a relative max for g because g prime, which is the same as f, switches from positive to negative. All right. The graph of f prime of x is provided. The areas of regions A, B, and C are 8, 5, and 2, respectively. If f of -1 is 14, what is the value of f of 5? Okay, so if we integrate from -1 to 5 of f prime of x dx, the fundamental theorem of calculus tells me that I get f of 5 minus f of -1. Well, we know f of -1 is a 14. We can find this because it's the area, and I was just given the area. We know this number. We know that f of -1 is a 14. So if I find the number for the left-hand side and I move the 14 over, there's my answer. So here's what I know. I know that A is an 8, but it's a -8 because it's below the axis. I know that B is a 5, and it's a positive 5 because it's above the axis. And I know that C is a -2 because it's below the axis. So A plus B plus C should be -8 plus 5 plus this -2. That nets a -5 equals f of 5 minus 14. When I add the 14 over, I get 11 equals f of 5. That's not an 11. Come on, brain. It's a 9. Sometimes my brain is sad. Just ignore it. It's cool. It's a 9. Sad brain. All right, so anyway, That's totally what should happen when you add 14 to negative 5. Anyway, all right, same idea. You're given that the areas of A, B, and C are 7, 5, and 1. So that's a positive 7. That's a negative 5 because it's below the axis, and that's a positive 1. Right? We're given f of 3 is 10, and we're asked what f of negative 5 is. So by the first fundamental theorem of calculus, if I integrate from negative 5 to 3, f prime of x with respect to x, I should get f of 3 minus f of negative 5. I'm going to go back and make sure I didn't forget my dx. I didn't. Okay. So I know, so this is given. I know this. This is a 10. And I can find this area, right? I can find this by using area, and then I'll be able to solve for this. So when I use this area, this integral from negative 5 to 3 is 7 plus a negative 5 plus a 1, which I'm pretty sure nets to a 3. And that equals 10 minus the thing I want. So I subtract the 10 over. I get negative 7 is negative f of negative 5. I divide by a negative and get that 7 is f of negative 5. All right, moving on. All right, so for t between 0 and 8 inclusive, the velocity v of t in inches per second of Bailey traveling along the x-axis is given in the graph below. If Bailey's initial position was 5 inches, so that means x of 0 is 5, right? We want to know the position of Bailey, not the particle. Bailey's not a particle. He's an awesome dog. We want to know the position of Bailey when t is 8. So we want x of 8 equals question mark. So here's the trick. V of t is x prime of t. So we know from the first fundamental theorem of calculus that if we integrate from 0 to 8 of x prime of t dt, we should get x of 8, which is the thing we want, minus x of 0, which is a thing we know. And you could use like b of t for Bailey if you want. I just didn't. I used x. It's fine. So I can find this area, right? So this is an area. I can find that, yay trapezoids, right? So if I want to find this area, this trapezoid has a base of 3 and a base of 7 and a height of 4. And I can find that this triangle has a base of 1 and a height of essentially negative 2, right? So I can find that area by saying, hey, this is 1/2 the height times the sum of the bases. And you could break this into smaller things. If you didn't want to treat it as a trapezoid, you could do it as 2 triangles and a rectangle. It doesn't matter. You just have to find the area. Plus 1/2 a 1 times a negative 2, right? So this area is going to end up being a 20 minus a 1, so a 19 equals x of 8, which is Bailey's final position, minus his starting position of 5. So when I add the 5 over, I get 24 equals x of 8. So his initial starting position is 24, and I think it was in inches, 24 inches. Okay. Second question, at what time is Bailey farthest right? Justify your answer. Okay, so farthest right is asking for maximum position, right? That's what that's asking. It's saying what is his maximum position, right? So essentially, what's happening here is when v of t is greater than 0, Bailey is moving right. Right? Bailey's moving to the right. Well, that means that that's happening from 0 to 7. So like from 0 to 7, Bailey's moving to the right. Right? T is 0 to t is 7. Okay? When v of t is less than 0, Bailey's moving to the left. So that's happening from 7 to 8. Right? So basically what's happening is he starts at 5 and he moves right for a really long time. This has to be the max x of t because he's moving right, stops, turns around, and moves left. So the max is happening at t is 7, right? So the answer to B is farthest right, right? So farthest right equates to the maximum of x of t, which happens when t is 7, because v of t changes from positive to negative, right? So essentially, we change from moving right to moving left, okay? So t is 7. And in fact, both of these endpoints are minima, right? Because if you look at what happens to v of t, right? If you made a v of t sign chart, 7, 0, and 8, right? And those are the endpoints. So there's nothing after these two, right? There's no arrow. So if you look at what's happening, v is positive and then negative. So what's happening to Bailey's position is it's increasing and then decreasing. So the two endpoints are both mins, and the only possible max is at 7. Okay? All right, you go ahead and try one, and this will be the end of this video. So from 0 to 7, and again, this is not a particle, it's a dog, because I changed it after, because particle was boring. So from 0 to 7, the velocity v of t in inches per second of Riker traveling along the x-axis is given by the graph below. If Riker's initial position, right, so initial position means at time 0, so x of 0 is 3. We want to know what's his position at 7, x of 7 question mark, right? So the first fundamental theorem of calculus, because remember that v of t is the same as x prime of t. So for A, the first fundamental theorem of calculus tells us that if we integrate between 0 and 7 of x prime of t dt, I would get x of 7, which is the value I want, minus x of 0, which is a value I know. So I can find this area, right? So I'm going to probably treat this as a triangle and then a trapezoid, because notice they do change shapes here. Here's another triangle, here's another triangle. This triangle comes out negative. So first triangle has a base of 3 and a height of 3, right? So this is going to be a 1/2 of 9, 3 times 3, right? This trapezoid has a base of 3 and a base of 1 with a height of 1. So 1/2 the height times the sum of the bases, right? Plus, this is a 1 by 1 triangle, so 1/2, 1 by 1, right? Minus, this is a 2 by 2 triangle, so 1/2, 2 by 2, and the minus was because it was below the axis. So I end up getting 9/2 plus 2 plus 1/2 minus 2. Yeah, it checks out. So I end up getting 10/2 or 5. Great. Okay, so I get 5. That equals x of 7, which is the thing I want, minus x of 0, which was a 3. When I add the 3 over, I get 8. So 8 is my x of 7. So x of 7 is 8 inches, right? That's my x of 7. At what time is Riker farthest left? Justify your answer. Now this one's a little bit trickier than the one I gave you in E5, and I'll walk you through why. So there are 2 times when Riker is possibly the farthest left, okay? Because if you notice what's happening, right, so v of t starts at 0. The only possible 0 is at 5, right? And then it ends at 7, right? Well, v is positive and then negative, which means that Riker's position is increasing, right, and then decreasing. So these are both minima, right? The question is which one's lower, right? So both t equals 0 and t equals 7 are minima, right? And it is worth noting that farthest left, so you should probably make the note that farthest left equals the absolute min of x of t. That's what it means. We're looking for the minimum, right? Because farthest left would be the lowest value. So both t is 0 and t is 7 are relative minima. The question is which one's lower, right? And I can even just say based on the sign chart that I gave you, right? So like based on this sign chart, so which is lower? Well, conveniently, because of part A, we already know the values. We know that x of 0 was given to be a 3, right? We know that x of 7 is an 8. Since this is lower, 3 is less than 8. At t equals 0, he's the farthest left. Now, there is another justification for that, okay? The other justification is if you didn't want to find those 2 values, you could argue that when you look at this graph, I'm going to do a terrible job of recreating it, but you get the gist, something like that, okay, that this area, positive, is bigger than the negative area, right? So the positive area from 0 to 5, yeah, from 0 to 5 is bigger than the negative area from 5 to 7. So there's a net gain, which is why the initial value is the smallest. So x of 0 is smaller than x of 7, and that's why it's the smallest. So that's another logical way to work through it. But so that's sort of the idea. This entire section that we've done with this video is very realistic to what you might see in AP free response problems. So hopefully it was helpful, and we'll move on to the next section. Have a good day.